Uh, Hello, Sakit. Yeah. So can you share your screen and see if we can? Okay. Maybe we'll start in 5 minutes. I just set up the live stream on YouTube. Uh,
Oh, Can you just let me know what you can see right now on my screen?
Yeah, we we can see your. One sec. Okay. Hello, Sakit.
Yeah.
Yes. Yeah, we can see your screen, but also we are seeing your the screen outline and everything. It's not full screen.
Okay, one moment.
So if you are okay, now we see your browser. Now we see our slides.
Yeah.
Yeah, if you click on the play, yeah, now it's good. Okay. And yeah, Sakit. Yeah, maybe we'll get started then.
Sure.
Sure. Yeah.
So, hi everyone. My name is Sakit, and I'm really grateful to Kiran for giving me this opportunity to talk at the React Bangalore meetup. So my topic for today is incremental static regeneration and using Next.js. And before we dive into it, just a little bit about me. I'm currently working as an engineering manager at Proximity Labs. Um a little bit about Proximity Labs. We're a global team of coders. We love open source, and we are all working from home at the moment. Um, we have open positions for senior full stack engineers. So after this talk, please feel free to reach out to us. All right. So specifically, when we're talking about deploying a React application, the type of problems I deal with daily are highly related to scale and performance. So these are two things that I have to take care of. So many people are working on side projects and React applications which are maybe used by hundreds to thousands of users a day. I'm talking about thousands of users per minute. So I'm talking about scale from there and above. So now the type of problems that you're trying to solve change. And keeping that in mind, that is the base, the fundamental that I want you to keep in mind when I'm talking about all of the things that come into picture when you have to take care of performance as well as costs and at scale. So let's just do a brief overview of what are the different ways we can currently deploy a React application. Again, there are a lot more. I'm keeping it quite straightforward and simple. I want to make this a little beginner-friendly talk. So first is static deployment. I think from 3 to 4 years ago, a lot of people have been introduced to React from Create React app, and it was the easiest way to start developing a React application. And building that application was quite straightforward. Even if you would have your own custom Webpack setup, it would essentially bundle out a static bundle, and you would host that wherever you could statically host a website. So that really changed the way people thought about static bundling, and it led to the whole Jamstack revolution. But at the core, you were building one static bundle and you were deploying it. And all of the data that you had to view on your pages would actually come from API calls which the client was making. So either it was hard coded in, the HTML was already pre-rendered, or it was coming in from API calls which your client was making. Now, of course, there were some pros and there were some cons. Biggest of them being the SEO wasn't so great. The entire bundle was needed. You would get the snappy app-like experience when it was shipped, but otherwise, there were other major issues when it came to search engine optimization. So then enter static site generation. And one of the huge uh, communities which has done a lot for static site generation is Gatsby. So Gatsby entered and they really liked the concept of what was happening with React, but they said, let's take it to the next level. And their target audience was um, news websites or media websites, like say People Magazine or BBC. And what they were trying to point out was that you have thousands of pages. So if you were to make your, if you were to build your website statically, you could actually get better performance scores and you could get better search engine results. So to do this, they said, we'll call the APIs at build time and we'll render the pages and keep them ready. And following the same thought process, even we have another very popular library, which is the one that I'm going to be talking about more, which is NextJS. And so this really caught on, right? The concept of static site generation, and people started really loving it. But there were fundamental issues that people had not thought of at that point in time because no one had actually implemented it at scale, which started surfacing about a year into people actually adopting it for production. I have to mention this third aspect of deploying React application, which is server-side rendered applications. So what do we mean by server-side rendered? Essentially, we are talking about implementing some code or implementing the data fetching on the server and then rendering the HTML and then serving that to the client. Now, this actually mimics the old way that we used to do web development, right? So if you are from a PHP era, you will remember that you had to, or WordPress even, you had to have the server and you needed to have the code render, I mean, the HTML render on the server, and then it was sent to the client. So we're going to just take a short look at how each one of these works in Next.js. And we'll start with server-side rendering. All right, so the core of Next.js, for those people who haven't worked with Next.js before, the core of Next.js is it is a framework built on top of React. And it has some opinions of its own. One major one being routing. So the routing in Next.js is file-based routing. So you don't have a client-based router like React Router DOM, which you would generally have in an application like if you built it using Create React app. But you have a file-based routing system. So you need to follow a certain system of how you name your files and where you keep them. And based on that, your routes are built. Now, most of React is as is, but there are some special lifecycle methods which are introduced by Next.js, which give us some superpowers, which help us with all of our performance and SEO needs. So let's talk about server-side rendering first. We have a function provided by Next.js called get server-side props. Those who've already used it know what it does. It allows you to actually run code on the server. It'll go and fetch the data. It'll pre-render your page. So there is my function for my page, and it'll whatever data it receives from an API. It could be a headless CMS. It could be an API which requires some different sort of authorization, and hence you're triggering it from the server and not from the client. So all of that is made available through props to the page. And this actually runs every single time you request the page. So this is the same way things would run back when we were building vanilla PHP websites. And they have specific use cases, but they don't cover most of the use cases. So we'll see what most of the use cases are like. Now, there's another very similar sounding function or lifecycle method that's been made available to us. It's called get static props. Get static props, even before I speak about it, I would like to speak about what do most websites actually look like. So let's actually take a look. All right, we'll look at two types of websites. So one is twitter.com. And what Twitter is essentially showing me is content which is user specific. So all of the content that I'm going to see on the screen now is very specific to the user that's logged in. If I'm not logged in, I see this generic login page. That's it. So note that whether server-side rendered or client-side rendered, just keep in mind this thought process that I needed credentials of the user. I needed some information of who is trying to access the page, and then the page actually rendered differently for that person. So this is one very large domain of websites, right? Social media networks, Instagram, Facebook, all of them fall under this category. And then we have content distribution websites. So I have on my screen right now bbc.com. So you could have a People magazine or Verge, and all of these are essentially spewing content by the hour, right? They are literally every hour they're adding about 20 to 30 articles on their website. And so across a day, they're growing by 500 different articles. And every article, so I'm just clicking on a link, every article has its own page. So that means the website is actually growing by 500 pages, right? In a way, in a manner of speaking, right? If this were entirely statically rendered. So if the entire website was statically rendered, the website is actually growing constantly, like on a hourly basis. Now, how do you actually create something like this? So keep with this kind of thought process in mind. At scale, how do you counter these sort of issues? Let's come and understand what get static props is. Again, most of you might know it. This is for those who are coming from a non-NextJS background. So get static props allows you to get static props allows you to fetch some data and render your page beforehand, but it stores the page statically rendered. That means it is served to your client, to your browser, as HTML and CSS in a manner of speaking. And neither is there a request being made for data on the client, neither is there a request being made for data on the server. So because no one's making a request for data, you get a very fast experience. You're just going to a URL and you're being served the rendered HTML and CSS. All right. So now with this background, we run into some problems when we are talking about scale. This lovely comparison done on CSS tricks of the build times with different site generators. It's a little old, but it will give you an idea that as the number of files that you need to build increase, the build time goes up. And if you are adding hundreds to thousands of pages to your website daily, how do you actually counter this problem? Because your build time is going to keep going up. Even if you have a machine which you specially have for just building and deploying your website, and you have millions of pages. So just to give you an example, uh, BBC has about 25 million pages which are accessed quite actively, and it has an archive which is much bigger than 30 million pages. So just to put things in perspective, the build times are in hours, and you cannot take that much time to actually build your website, because by then you would have actually written more content and you would want to redeploy that. So around April last year, NextJS announced something quite revolutionary. They announced static generation at scale, which they like to rename incremental static regeneration. And what they're essentially saying is they can infinitely generate and pre-render new pages. So, I mean, this is their official blog post from July when it became stable, where they're saying Next.js can statically pre-render an infinite number of pages this way on demand. Now, this is kind of fascinating. Let's actually see how this happens. They have an example. Let me see if I have popped it open. Yeah, all right. They have an example running over here. And what they've done is there's a GitHub issue over here. And on this GitHub issue, you have people who have reacted to this comment, and they're taking those comments and they're showing it on this page. I'm just going to comment on this page as well. So I've changed a certain comment. Now the smiley faces are 344, 343. If I duplicate this page, right, it's going to just re-render. What I have been served is the cached version of this page. All right, but every page has a life of 1 second. I'm going to just reload the page now. Let me just, yeah, all right. I guess GitHub took a little bit of time to reflect that change. So I'm reloading the page, and now you're seeing the number has changed as well. But if you also noticed, I first saw the number 342 on page, and then I saw 343. What happened? I was served the old statically generated page. So I got a very quick user experience. On top of that, it went and checked. So it's using what we call stale. I mean, it revalidates when it considers it to be stale. And we can define a timeout for when the cache should be considered stale. And this particular page has been defined a timeout of just 1 second. So for that purpose, it actually went and checked, is there new information? And when it did find new information, it rendered that new information on the backend. It statically cached that page as well, and it served it to us. Let me show you one more example just to get an idea of how amazing this is. So that example actually happens to be here. All right, so I'm going to just head to this page. It's static-tweet.now.sh, and it's followed by tweet ID. And if you saw that this page was instantly shown to me, what you're seeing is there is no embedded tweet here. So if I refresh this page, it's literally served instantly. The tweet is in line with my HTML. So I can actually inspect this and see that the tweet is completely there with my HTML. And if I check my networks tab and I check all of the requests that were made, there was no request made, there was no fetch made from my client side, which was actually going and getting data. Now, if I were to take a tweet ID which did not exist, this is where the entire situation comes together. If I were to take a tweet ID which did not exist, so I'm just going to randomly fetch a new tweet. All right. I'll just copy this tweet ID over and I'm going to paste it over here. Okay. So I'm heading to a page which both you and me know that there's a fairly recent tweet. It is not available. It is not statically cached and generated beforehand. What we're presented with is a loading screen. I don't know how many of you saw that, but for a very brief second, there was a loading screen. So there is a fallback that is shown for those pages which are not generated, which is a loading screen, and then you are able to actually see the statically generated page. So this is what they mean by infinitely dynamic static generated pages. So let's get into a little bit about how this is actually happening. So there are two more components to the methods that we are talking about already. One of them is get static paths. Get static paths is used whenever you have dynamic paths. So let me just show you an example of what get static paths looks like. Like I told you before, the routing is based on the name. So rather than having a slash posts and a slash say 123.js, which would render as your domain slash post slash 123, you can actually have a slug over there. So the slug will change over time, and based on that slug, you can actually get our query information. And so you can add a get static paths method over here to help you with defining exactly which pages should be rendered. But additionally, it has a fallback option, configuration option that you can pass in as well, which if you pass in it to be true, then what happens is it calls this, it revalidates this live behind the scenes, and it allows you to show a placeholder. So you get access to this placeholder by using the use router from Next, and use router exposes a is fallback boolean. So you know that, oh, this page hasn't been rendered, isn't statically available, but no problem. It's fetching it in the backend, and in the meantime, you can show a loader. And that's exactly what we saw, right? So I just want to talk about one more item of how you can actually implement incremental static regeneration. And again, just want to kind of drive this point home of what exactly it is. So if you've understood the concept of what static generation is at build time, we're going and fetching data, and we're creating our static HTML and keeping it ready so that we get these really performant websites. They get served really quickly, and they're very search engine friendly. At the same time, incremental static regeneration is, if that page did not exist, we will go and make it ready and keep it cached, right? So now, the get static props, which we spoke about earlier, also exposes one additional configuration option, which is revalidate. So revalidate allows us to set in number of seconds when the page is considered stale. Now, let me just draw you a picture of where this would actually make a difference. Let's see if the BBC website actually has this. Yeah, okay, this is actually a perfect page to take as an example. Now, what you can see on the right-hand side is top stories. What you see on the left is the post itself. Now, there's two things over here which trouble a lot of people who build static websites. So this is an ideal case to build a static website. You want your search results to come on top when someone is searching for relevant news item. And to make sure it is on top, Google is from March 2021, Google is taking into consideration the performance scores as well when they're doing your ranking. And for that reason, you need to have good performance scores, and it's like a no-brainer. You should have a statically rendered site. That being said, while you can statically render most of the content on this page, which is the core information, what about components like this? So you have a top stories component, and the top stories by literally by its name has to be updated frequently. There's two ways to do this. This component does not need to be statically rendered, right? This component can actually make the call from the client, get the most recent top stories, and then populate it over here. So while the person is actually reading the rest of the data, and API call separately is done. At scale, what happens is this puts a load on the server. So when thousands of people are accessing this page simultaneously, thousands of API calls are being made to the database. I'm talking about per minute. How can you prevent thousands of calls going? So you can statically render this content as well by making sure that you add that into the data that you're calling inside your and serving inside the get static props function. And then you can set a revalidate to 1,000 milliseconds or 600 milliseconds. So it's about a minute long. So for a minute, you have stale data on the website. But that's not bad because 1,000 people are looking at top stories, and this widget or this component is just showing you data which is only a minute old. So if you have literally a story, if let's say this component was populated by information based on the last posted story, then you would immediately post a story and it would immediately reflect over here to the person who would access the website a minute later, right? And that website would have been served statically. So do remember this, the first person visiting that website when it's stale, he would get a old version, but there would be a background request to check if there's something new, and then the new one would be saved, right? When you implement this at scale, the cost savings are magnanimous. Like I cannot even go to, I mean, we are helping companies out with problems like these. So it's about a 30 to 35x decrease in server and backend costs, right? And their running costs because of their daily active users are already high. So you can already imagine how that has an impact. All right. So coming back, this was my little lightning talk on incremental uh, static regeneration, but I think they've missed out an opportunity. They should have called it infinite dynamic static site generation, because I just think that drives the point home much better. Okay, so thank you everyone. If anyone has any questions, please do ask. Sorry, there was no live code. Some technical glitch at my end, so I wasn't able to present a live working version, but I hope you enjoyed it nonetheless. If anyone has any questions, do go ahead.
Hi Sakit, nice talk.
Thank you. Yeah, can you take
I'm just looking at YouTube if there are any questions.
All right,
Uh,
yeah, sure. In the meantime, I would just like to say that Proximity is searching for senior full stack developers. If you have and designers, senior product designers. So if you have 5 years experience plus, and you like working with relatively modern stacks, uh, drop your resume to me or just ping me.
yeah, Sakit, we have one question.
Yeah.
Like if I use revalidate Is the entire page rebuilt or just the part that needs update?
Okay, so all of the methods that I mentioned, get static paths, get static props, and get server rendered props, all of them can only be executed on a page level. So the entire page is going to be rebuilt, right? And that is why setting your revalidate matters. But even if your revalidate is set at 1 second, which is not something practical, but even if it was set at 1 second, when you have millions of users visiting your website, you will still see a benefit, because concurrently there will be only one request every 1 second. So if you had set a cache time of say a minute, which is something more practical, because then you know there would be exactly X number of requests in a day, uh, based on the fact that you always have visitors on your website, then what's essentially happening is your page is being rebuilt. And this is important. It might even take time for your page to be rebuilt. So one person, or that person who's coming and accessing the page much later, and it's not valid anymore, the cache is not valid anymore, so he's seeing a old version, and in the background the new version is being built. That person will see, maybe it'll take some time, and then he'll see a change to the website. But the first version that he sees is the old static version, and then he will see the new one a little later. And in the case of what we saw, the Twitter demo, where the page did not exist at all, there the person would see a loader for a relative amount of time, right? So keep that in mind. Any heavy, say, HTML rendering and inlining work that needed to be done can actually happen on the server. Static page can be generated. And even if it takes time, 30, 40 seconds, that can all happen on the backend.
Yeah. So
Yeah. So one.
one more question is, can we achieve the same using get server side props?
Yeah, so there's a with get server side props, it will make a request on every request. So if you are making a call to a database or a headless CMS with get server side props, you are essentially, every single request to the page is making that call. So you are not saving, and your total blocking time is actually going up now, because the page is taking longer to be served. Now, realize your server is going to take some more time to calculate, render the page, and then serve it. So it's going to take a little longer for the server to serve it. It's going to take a little more time for the client to actually see it. Whereas in this case, we are serving a static page. So they're slightly different from each other. And what we want to try to do is serve everything statically, but the content should be dynamic. So that's what we're achieving over here. I hope that helps.
Yeah.
Hi, Sagar. Are you able to listen me?
Yeah. Hi,
Yes.
Sandeep.
Yeah, nice talk. You have given a nice information over there. So last minute, I have a query that last minute you spoke that, let's say you have loaded the BBC News, okay, and the
Right.
top stories component, it is showing that you told that whenever the user will load the BBC site, we will immediately show the static pages and on the top stories segment component also.
Exactly.
Okay. And let's say at this instance, immediately, let's say 1000 people requested for top stories. Okay.
Right.
So,
Perfect.
so after you told that, for the time, let's say we will take 1 minute of a year time for make an API call. Okay. So
Perfect.
after 1 minute at current instance, let's say 1000 people have made a request. So after 1 minute, it will not put load on the server for that.
No, because it's making only one call. So let's say in 2 minutes, 2000 people visit your website.
Hmm.
Only 2 server calls are being made.
Okay.
Because
Rest
that first
on,
person,
on the rest of the people you will show on static.
the
Yeah.
static generated page. Yeah.
Okay, and rest you will keep them on with on the dynamic side
Yes.
on.
No. So there, everyone will view a static page. And also note this, the person coming, I mean, this is again just, we're talking hypothetical situation, but the person coming, as soon as the cache gets stale, that person is going to actually view the old page. And in the background, so he's also going to view a static page. But in the background, one additional call is going to be made to the database, and then a new page will be served.
Okay. First, you will cache the complete page over there.
Exactly. And then that new page will be replacing the old cache. So
Okay.
it'll
Okay. When
be a
a new request is made, it will again automatically be saved in the cache only, na?
right.
Okay. Okay. Fine. Thank you. Thanks a lot. Nice talk.
Cool.
Sakit, we have one more question.
Yeah.
So the question is, what will be the behavior on the first time after restarting the BBC site?
First time after restarting the BBC site. Yeah. So that's a good question. That's exactly what I was trying to show you with the Twitter demo. Let's say let's say you have a headless CMS connected to this system, and your entire publishing team is actually putting content inside the headless CMS. So there's a slug that has been created, but no one has accessed it yet. Let's assume there's a post which has not been statically generated yet, and you go to that post. Let's say it's India versus Corona, something like that. So bbc.com/India versus Corona. When that first person hits that website, he does not have any static content to be served to him. Fallback is made available, right? We have one special prop made available to tell us that, hey, the static content doesn't exist yet, but you have said that fallback should be true. So we're going to check, can we actually statically generate the page now and serve it now? So we use that prop to show a loader to that user, and they view a loader until the backend is statically generating the page. And once it's available, then they see the page. And Next.js takes care of all of that for us, right? So that first person is going to see it. But everybody else, even if you do a redeploy of your pages, they're going to view the old static pages first. You can also specify to make your cache not valid on every deploy if you want to.
Okay, I think the follow-up to that is Tristan is asking, like, if there is any new deployment, can we still keep the old generated files and only build the new files?
Yes, absolutely, you can. So I would like to put it a little differently over here. Think of it like this, that at build time, you're actually not building anything. Right? This is little revolutionary now. At build time, you're not building because there's so many pages. You don't want to build at build time. You are building when needed. And then you are caching those pages.
So for example, the Nest.js doesn't invalidate the cache when we redeploy?
No, Next.js will, you have to give it specific a configuration at the time that you're deploying to tell it to invalidate or to retain the cache. Okay. So you have that choice. You can tell it to invalidate the cache.
Where can we find this information about this deployment configuration? Is there any place we can find?
Next config JS.
Okay. Got it.
Yeah.
So one more question from Japneet Singh. Is this concept only worth it for large scale projects, or is it worth implementing in small to medium scale projects as well?
So I would highly recommend that this be implemented by everybody. This is a very good question. Now, why? Think about it like this. Even if you have a normal blog, very normal blog, 10 pages, okay? And you're going for a static site rendering. What would happen if you made a typo on some page? You would your blog is sitting in MDX files, the content of your blog is sitting in MDX files, or it's sitting in some headless CMS. You would go into one of these places and you would change it. Now, once you have changed your content, you would need to again redeploy your website for the changes to reflect on your statically generated pages. If you use this technique, The moment the person is accessing your page next, he's going to view or he or she is going to view the cache, but it's also going to invalidate. I mean, it's going to know that, oh, this cache is stale. It's going to rebuild. It's going to go and check for new content. It's going to replace all your typos, all your errors, all your banners with update messages, all of that. And you have not had to run a deployment step again. So I highly encourage everybody of all project sizes to use this where needed, right? So if you have some sort of website with a directory page, like something like a Just Dial, and you have multiple different businesses you're listing, you have maybe a list of doctors on your website, and they all have their profile pages, or blogs, right? They're all similar sort of content, right? I would highly recommend, even if it's a small number, because just think about it, that person can dynamically change his information from his profile view, and you are serving static content to people so that they get really quick websites. So you can, if you have like this, you're a website which is listing all the gyms across India, you can have quickly come to the top of Google rankings because your static pages you have for every single gym listing.
So one more question is, can we write rules based on cookie or query parameters to statically generate pages?
At the moment, it is page based, right? So when inside your function is actually getting executed on the server side. So you can have a rule which is defining what should happen. So static paths is primarily for that. Based on the query or based on the URL, you can define what should happen. Should it be static or not static when it's served? Additionally, and do note, this is very important, this is the ideal way of serving all of this information. But if you would like, you can have one more layer added inside your client, which will double check कि ये statically generated content hai ki nahi. So you can pass some parameter like a timestamp in your data कि when it was rendered last in your props, and that can allow you to control whether an additional call should be made from the client and the information should be replaced. If you want to override the backend static regeneration, revalidation process, you can actually have the client do it by having a use effect sitting in the client, checking for the data, and you can pass some additional props in the data which the client can access. So this is possible. I don't see a very clear use case for when you would want to do something like this, but do note that get static props will be executed inside the server. So you won't have access to cookies. You won't have access to your query params. You will only have access to the URL itself, the endpoint itself. So you will need to get innovative. That's why I said something like a timestamp might be something that you want to insert.
Yeah, I think Sakit, that's all the questions we have for now.
Thank you so much, everyone.
Yeah, thanks Sakit. Thanks for the nice talk and also answering all the questions. And so yeah, so we have that at the rate Sakit course. If you have more questions, you can reach out to him on Twitter, or you can email him. Okay, then we will move on to the next talk then. Bala?
Yeah, sure. Thank you.
Yeah.
Just share my screen.
Yes.
Let me know if you are able to see, then we can start.
Yes.
You want to see, right? Okay, fine.
Yes.
Okay, so we were talking about integration testing with MSW. So before we start, I'll just give you an idea of who I am. So I'm Bala Vishnu, and I work at Healthify Me as an engineer, mostly in front end. Mostly I work on React and React Native projects. That's what primarily I work at. So yeah, that's more about me. If you are interested to know, there's a link which you can get more information. Okay, so what we want to talk about in this test is why integration test, why I'm focusing on integration test, why we shouldn't be focusing on mocking library specific or pattern specific mocks like if you have Fetch or Axios. and how we can use MSW to make it better. And if we get time, we can do some bonus things also. Okay, so why am I focusing on integration testing? When you're writing tests, the problem is if you're mocking too much, right? It is easier if you're mocking a lot of things. It's easier for you to mock, easier for you to write tests. But the problem is the more you mock, the less confidence you have in your test, because that's all the things which your actual users might not be used to. But again, the problem if the two ends to integration testing, one would be unit tests, another would be an end-to-end test. Unit tests are much easier to write because you can mock every scenario and every test case you want to test. At the same time, end-to-end tests, those things are difficult to create each and every scenario for your test. So integration test becomes a balanced place where you are mocking as minimal things as possible. At the same time, you're testing as many use cases you could do. Also, because you're doing the same thing, you're also able to see how your application is going to work. Like now, if you read a test, you would be able to understand, okay, hey, this is how this page interacts with the user, and these are the cases you have in specific to this page on this specific module. And if something goes wrong, it's much easier to catch those bugs in and if the test relies on something which a developer can run on his own machine. Because if the things run on end-to-end tests, and most of the people, we don't run end-to-end tests in your local, we just rely on CI to run those tests. And breaking way too late in a development process is difficult to fix also, right? If let's say while creating let's say ordering something, and your order the page failed. Now, in end-to-end test, it's difficult to figure out why did it fail, because of the API failed, or is something from the front end failed. That's difficult to understand. So integration test, you're just mocking. So everything relies in your own domain. At the same time, you have the confidence of your application. So having said that, this is a baseline I want to set why I'm focusing on integration tests, not on other two ones. Though the whatever concept you are learning today, how MSW works, you could apply it on either from unit test till end-to-end test. You should be able to apply them at all the cases. So why have we uh, are we focusing on not mocking library specific? Or when I say library specific, fetch is not a library, but let's, for our easiness, let's call it a library specific, because and you have libraries like Axios and other request making libraries, and then you have GraphQL has multiple adapters where you're making GraphQL requests to, right? So a lot of different ways of libraries, and each one has its own trade-offs. So you pick a library for you to based on your application. Now, the problem comes up when your testing also relies on your choices of your request making library, right? So if you choose let's say you started with Axios, and you later realize you're not using any features of Axios, and you're shipping a library which your users are not going to use. Let's go back to fetch, and a very lightweight polyfill would work. And the problem, if your fetch and if your mocks are looking like, no, there are mocking libraries for Axios, and there are mocking libraries for fetch. If you're using a specific one, migrating from one version, from one fetch to Axios will be difficult, because let's say when you have test and your application, and let's say you're changing if you're changing one at a time, then it's easier. Then you have a confidence. Let's say you have tests and you're changing your application, and your tests are still passing. Then you have the confidence of your refactoring the code. Hey, everything works well. I don't have to worry about anything. Or when you are changing the application or changing the test, and your application remains same, so you're adding more test cases, or finding a bug to a test. So you have more confidence. Your test saying, hey, my tests are working as expected in the application. But if you change both of them, in case if you want to migrate from let's say from Axios to fetch, you're changing your code because you want to change your code wherever fetch was used, you want to use Axios. And the same thing happens in your test also. You want to change all the mocks where you're done. Now the problem is both of them are changing at the same time, and this gives less confidence, because a lot of things are changing at the same time. So not only if you're, let's say you don't want to switch libraries, or even let's say tomorrow a library, whatever library you're using, let's say in Axios, and they come up with a breaking change. It would be very difficult for us to realize that things are breaking if a version upgrade had a breaking changes, and your mocking library might not be exactly mocking the way it has to, because your test might still be passing, because you're mocking the entire library itself, uh, and your application might be breaking. So that's a false positive for. So that's what we want to focus on, why MSW solves this problem. So I can give a quick demo of it. So we have a very simple application which just if you select a breed of a dog, it shows a dog's photo, and you can randomly ask for another photo of the same breed. So you just click and you get another breed of the same photo. This is the application, the entire application. You are able to see the code, right? Hopefully it's visible to you. So it's just a list of breeds, and then we have image to show, and a button to fetch a new dog. That's entire application how it is. And we are just getting an image as soon as the page loads, and we are changing them whenever effect changes. We are just basically fetching the dog again. So there are two services. I'm using fetch over here. There's two services. One is fetch dog breeds. So you're just fetching fetching the image of a specific breed, and you're fetching the list of dog breeds, which is to fill up your drop down. Okay. So let me. Yes, MSW is mock service worker. If sorry, if I was. Okay. I'll show how you generally write a test with fetch. So what we're doing is before we started rendering the app, I am mocking the first response, basically list of breeds. Then I'm rendering the app so that as soon as the page renders, my drop down gets filled. Then I'm trying to select which is the what is this drop down. Then once the drop down is mocked, before I click, I want to mock the next API. This is basically the image, the API which returns the image based on the breed. And then I'm clicking on it. And then I'm verifying the image was loaded or not. Then again, I'm mocking the response of the breeds API so that a new image link is returned. Then again, I'm clicking on the same button, the random button, and then I'm waiting for the image URL to change. This is what we're doing. So the you would have already realized that one biggest problem is you do not know what API you're mocking, right? You're just mocking the entire fetch. You're not verifying whether this can kind of be, we can fix it by expecting, let's say, you could just say expect, fetch to be called with particular URL or not. That might, fix this problem for you. But the problem is, again, it's not as easy for you to read called with, let's say, whatever the URL you want to test with, right? So that's the problem with reading how it is. And also you also noticed the order in which you're mocking things also is important, right? So now if I had mocked this thing way before this, let me just run the test. If I'm testing, let me just run. Yeah, there's only one test. So right now the test should pass, okay, right? So let's say if I have accidentally moved this mock on the top here itself, okay, now the problem is your test would fail. The test didn't fail either. So the problem is this is what it's getting mocked, and it's your list is actually not working well because your list API got regenerated, right? So that's, I think the application wouldn't work there. So that's the another problem. It sometimes gives you a false positive on how your APIs are mocked. So let's try to migrate this from fetch to mock service worker. Just to clarify, your test just runs on Node. It does not have service workers. It's just patching Node request library. There is no service workers in Node. Just to be sure of this, the library can be used in a development time also. If we get time, we can look into that also. Okay, to start with, I just take the doc and just let me just quit this thing, and we'll add MSW to the dependency and defining the mocks. I'm just going through the documentation. So the reason is so that you can also try this at later at home. And I'll try to push all the code and things on GitHub later. Okay, so I'm just creating a directory with mocks. Okay. Yeah, mocks exists, so that should be fine. and then I'm creating a file with handlers. This is going to be where we are going to store all our mocks. If it are smaller projects like this, you can keep it at one place, but if it's a bigger project, you can keep inside every test also. That's also fine. You don't have to keep all that at once. We are going with REST API, so we'll just see how to create REST API once. So we want to, in our handler.js, I'll just open my handler.js. This is the file we just created. I'll just copy this example from here and just paste it, and we'll change the things whatever is inside. But yeah, this is a basic how it looks like. So I'll just delete a lot of there's too much things. So you would see the mocks are which quite easy to understand here. We're just saying here res.post. We're basically expecting a URL and request and response to basically to figure out how you want to respond. So what we will do is we'll copy the first. So here we do not know which API we want to mock. So we'll go here and we'll just copy the list API which you want to mock. We'll just copy the URL. And we'll just add over here as this is the URL. So if it's local API, you just put a relative path. You don't have to put the domain, but we are actually mocking a different domain. So we'll just put the entire URL. And we want to respond with a JSON. So let me just copy the response. Status is fine, that is fine. That's okay. I'll just say settings.json would be this is going to be our test data whatever we had here. So I just copy no, this one. Yeah, this is the list API for us. So I just copy this and I'm just going to paste it over here, and this should ideally should just work. We don't need these things. And this is going to rest.get. Right, and this should be okay. We'll add one more. This is going to be our okay. I'll just add one. I just want to show you a thing, features also this thing also. So I'll just remove this for now, and I wouldn't want to mock fetch. I'll just comment it out here so I can remove it later. And I'll just go to setup.just. This is just resetting the mock and polyfill for fetch. That's also not there. Fine. Okay, this is fine. We'll see how to integrate. We want to integrate on the node. We'll just create another file for this. And we'll just fetch all the server.js and here. So these are the handlers we defined before. We just defined one. We'll define the other one a bit later. But yeah, so this should work. Yeah, so now in your this could be based on your setup, if or we can just keep it in our individual test, depends on how use case based. But for simplicity, I'll just keep it on the test we are writing, but this could be in your setup tests too, so that should not be a problem. So what we're doing here is we got a server from the server.js, and we are just listening, and while listening we can say, I think unhandled request, we can say warn. This is also a very good debugging tool, which lets you know if you're not mocking any API. That's what I want to show here, right? Let's say I just save it and I just test watch. So it should at least run the first part, but ideally it just should break. Yeah. So now what you see here is it says, hey, we captured a URL. We are not intercepting it. Are you sure you want to do that? That's because we are saying warn if I'm not mocking. This is also very good. This is the reason it helps in our integration test. Let's say one of your component is actually making, and a sub component is making the API call. It will be easier to detect what API calls needs to be mocked, right? So we'll just do one thing. We'll just copy this URL, what needs to be mocked. We'll add it our handlers. So what we let me just yeah, this entire thing I wanted to be copied. I just copy this entire thing. And I'll just copy this URL which needs to be mocked. URL can be parameterized, but I just for simplicity, I'm just copying whatever in the request. And the response is something we expect it to be this, right? We want this as the response. So just copy this as a response. And I'll just erase and I will change it here. So API response has changed. So I'm just saving it. So now if you would see our test, yes. So this is new image. We expected a no image to be there in the test. So that should be fine. Zero. Okay, fine. So these are test second test. Let's go. So now I'm just removing these. This is the first part of the mock. We don't want this is be handled in the let's say. Now this is a use case where you want to change the mock based on just before the test you're doing some action, right? This could be here in case because before us a random URL is hit, I want to change the response to something else. So what I could do is I'll just go here. I'll just copy the same response from here and I just paste it over here, and I'll change the response to new image. So basically, I need to get rest, so I'll just import rest from. I think that's the right import. Hopefully, so this should actually, yeah, that's our migration from fetch to mocks also. Now, if you see here, another biggest thing is your handlers you could keep it in a different place without having to rely on which order you're mocking things. You're defining the URL based on you're seeing what the response is. And also, it also gives you the flexibility of changing the response runtime in your test. So that's also a feature you want while you're testing. So this helps you in testing particular use cases and stuff. This is more on how you migrate from fetch to or any library. So if I go and change this to Axios, so the thing you notice here is it doesn't matter what library you're using. If I change to Axios, it should still work fine. So the bonus feature what I was talking about is we could still use this thing in your browser, right? So that's the thing which helps you in let's say your backend is not ready, right? Or if you let's say your APIs or your system is slow for some reason, you're not able to access, you do not have internet connection or some reason, you want to mock the APIs in your development server or local server at the same time without having to change too many things. So that's what we'll see. How easy is it to do it with MSW if you already have a list of mocks for your tests. Or it could work vice versa also. While you're development time, you can define these handlers and use the same handlers while you're writing tests. So I just create the public path is defined basically from where your index is filed. If it's a CRA, that's public, and other files for next few other things, common projects, MSW is listed down. If it's not from these things, you need to know where your static file is being served from. I'm just creating MSW a service socket file. It just creates a service socket file. Let me just see if I can show you. Public folder, it creates a mocks. You're not supposed to do anything with this file. It just generates. So you just don't have to worry about anything on that. And let me see, this is done. And I need to create a browser.js. I'll just do that. Mocks, fine. This we need to do it in the browser.js. So this we are just it's the same thing. So if you see here, the setup worker is for your client, and if you go to our server.js, it's setup server. So that's the only difference you have. If you're running in Node, you need setup server. If you're running it in your browser, you just need to import setup worker, right? It works well. To start the worker, we'll just need to put this line of code in your in your index.js to start. Yeah, this is where it starts, right? So before I save it, show this. So it shows how much data was transferred when I'm changing the API. It says where it's loaded from and what time it took. So what I do now, it isn't saved. I'll just and I should just refresh this page. So it should have docs here, fine. So now if our API worked, it should have only one mock. This is one thing what we're seeing is the only response we had it here. So if you want to mock to more response, you can say some other breed, and I'm just keeping the content same. I'm just keeping it like this. And if I just refresh it over here, you would see. Oh, sorry. Now the mock isn't working. Let me just. Yeah, so if there is a delay, or if initially if your if your API uses it's used before your app starts, you can just wait on uh, package also. That's fine. This is how you are mocking, and if I select something, you'd see. So here you will see it's been transformed service worker, not from your actual thing. So we don't have some other breed. That's why it shows 404. I think if we select our African, it should show some. I think it's pages 404. I think we didn't mark for a particular request. I think that's why. At you would see here how you are mocking the APIs, right? Yeah, I think that's how what I wanted to show regarding the fetch. We'll just go back to the slides. So that was the bonus content. How if you are creating a handler for your test, or if it's for your development, either one, you could reuse the same handlers for the testing or for your development. So yeah, any questions which I could take? This is what I wanted to share.
One second.
Oh, okay. Let me see why it doesn't work. Oh, okay. So let me just. We mocked with an URL that did not exist. So handlers. So you could use actually API to get a image. Yeah, this should give me a actual image instead of a dummy URL. So we can change from this to an actual image instead of a dummy URL. Yeah. So this should give me. This still doesn't work, but African should now have an image. Yeah, that's an image.
Vala, we have one question.
Okay.
Bhupati is asking, can you please compare this with knock, which they are using?
Yeah, knock kind of does few things like this. So one of the biggest thing is I don't think knock you could use for both client and your tests, which you could use it here. And the APIs for knock is bit different. The APIs you define here are much easier to understand. And also, I think there's a comparison in the documentation on the site itself. Where you could see how it compares with other libraries. Yeah. Are you able to see my screen, right? So I'll just
Yes,
show
yes.
what it is there. Not sure. Yeah. I can share the link if it's want, but yeah, basically you could knock only works in your node. This works in both the places. How its internal workings, I think I can share. Doesn't require. Also, I think knock requires adapters for you to use in other libraries. So I can share it in the YouTube link. I'm just sharing the link where you can go in detail if particular is not.
Okay.
Right?
Yeah, I think that's all the questions we have.
Okay. Yes.
Well. Okay, then I think for this meetup we have only 2 talks. Uh, yeah, and also, next month we are organizing a conference on March 19th and 20th. It's the URL is reactday.in. Uh, so do check out the conference, and maybe you can attend the conference as well. In March, we might not have any meetups because of this big conference, but then we will again resume the meetups back in April. Yeah, so I think that's all we have for today. Maybe we'll catch up at the conference and then again in the meetups in April. Thanks everyone for joining. Yeah, thanks Sakit and Bala for their talks. Yeah, see you again.
Hi,
Bye.
Kiran. Kiran.
Yes, hi.
Yeah, Kiran, could you please share the link
Yeah, for link for what?
for the React conference?
It's reactday.in.
Reactday.in.
Yeah.
Okay, fine. Thank you. Thanks so much.
Okay.
Mhm.
Yeah.
Okay, then we'll catch up next time then. Bye.